Yeah, by now, as you have the clarity on what is a pod and what is a container, now let us take up the architecture of the Kubernetes as a whole, and inside the architecture, every component in detail. Okay, so Kubernetes architecture means it is a combination of two things. You'll have Kubernetes Master and the workers, nothing but the worker nodes. Okay, now coming to the Kubernetes Master. The master has got four components: API server, scheduler, controller, and etcd or etc. So let us take the Kubernetes Master, and the first component in the master will be the API server. So any interaction with the master machine is done through the API server. kubectl will communicate with the API of the master machine. As a user, when you are using kubectl, all the communication will be done with the API server of the master machine, and the API server receives all the information from the user. So if you see, as I said, the Kubernetes cluster has got a master and nodes or the worker nodes. How is that you are going to control this cluster? So it will happen using two ways. One will be the user interface way, another one will be the CLI way. The user interface we are not bothered. To learn advancedly Kubernetes, we have to go to the CLI way. In the CLI, the name of the CLI will be using will be kubectl or kube controller, which is a CLI. CLI stands for command line interface. So this kubectl or command line interface, which we will be installing in a different machine, which has nothing to do with the Kubernetes cluster. So the machine in which we are going to install kubectl or kube controller is called workstation. So by this you have got the clarity on API server. Okay, so user will pass the instructions to the Kubernetes master, and in the master, user instructions are taken care by API server, in simple words to say. How is that user will pass the instructions to the API server? Using a file. The file name is called YAML or YAML file. Now let us go with the second component, which is nothing but the etcd or etc, also called key store. All the information received by the API server. Okay, now API server, whatever information it receives, it has to store into some location. That location is called etcd. Okay, now in the YAML file, what user is giving the instructions to the API server, in the YAML file it will have, there will be a desired state. That desired state is read by API server, and it will store the desired state in the etcd, also called as key store. So what do you mean by desired state? In a layman example, if you have ever gone to a pizza center and ordered a pizza, so what will you tell? You will tell that you want a particular pizza, let it be a veg or a non-veg, and of a particular size, it is a medium or a large. So for example, if you say you want a chicken pizza with medium size, so that is a desired state in your layman example, or in this layman example. So the same way, here the user using the kubectl, using in the YAML file, there will be a file called YAML file. Okay, he will say, for example, I want 10 pods. So in the YAML file he will write and say that he wants 10 pods. User will say he wants 10 pods. So that YAML file which is having the desired state of 10 pods will be read by API server, and API server will immediately save the desired state into etc or etcd. Clear? Now let us go with the next component in the master, which is the controller or manager. So the work of the controller is to check what is the desired state you have given in the etcd. So what is the desired state in the etcd? That is what your manager will check, manager or controller. Once the controller reads what is in the etcd, the controller will immediately check what is the actual state on each and every node, and the manager will compare the desired state which is in the etcd with the actual state in the worker, and based on the difference between the desired state and actual state, the manager will take a decision, or the controller will take a decision. So for that, controller needs to receive information from each and every worker. Once it receives the information from each and every workers, it tries to check what is the desired state. The controller component in master is the one which tells to create how many replicas or pods you have to create. So in my earlier example, as I said, if the user says he wants 10 pods, so currently if you see, worker 1 has got 3 pods, worker 2 has got 3 pods. If additionally user is saying if he wants 10 pods, then in the etcd the user's desired state of 10 pods will be memorized, and my manager will get the information from all the pods and compare. So if you see, the desired state is 10 and the available actual state is what? There are 1, 2, 3, 4, 5, 6 pods. So 10 is greater than 6. Now the controller will plan in such a way that additionally 4 pods are made available in this cluster. So what will controller do? Controller will be monitoring the entire state, nothing but the desired state and the actual state. But controller does not communicate directly with the workers. Here controller will never communicate directly with the workers. Okay. Now if you see, let us go with the next component, which is a scheduler. So what will the manager or controller do? Controller will handle the workloads and it will allot the workload to the scheduler. So it will only do the judgment, but the implementation will be done by the scheduler or the scheduler component in the Kubernetes Master. Scheduler is the one which will be taking the workload and implement it on every worker machine. So at the end, controller will pass the work to the scheduler, and scheduler is the one which will communicate with the worker nodes. So as I said, controller will never communicate with the worker nodes directly. It is a scheduler which will do the communication with the worker nodes. So to sum up, user who is having a separate machine with kubectl installed, in that machine we will tell where is the Kubernetes master or the API available. So the user will communicate using the YAML file. In the YAML file, user will tell the desired state, and the desired state will be taken by the API server, and API server will store the desired state into etcd, which is a memory type of location. And in the etcd, what is the desired state? That will be read by the controller or manager, and manager will get the actual state available on the worker nodes, worker 1 and worker 2, and he will compare the desired state with the actual state, and he will make a decision, and based on the controller or manager's decision, the work will be allotted to the scheduler. Now scheduler will communicate with the worker nodes directly, and it will ensure that the desired state is maintained. So this is to sum up in short. So as we are done with the master's components, Kubernetes master component, let us go with the worker components. If you see worker node 1 and worker node 2, the components are same. So the main components are Docker, Kubelet, Kuproxy, and in worker node 2 also we have Docker, Kubelet, Kuproxy. So if you understand the components of one worker node, the same will be applicable to the worker node 2 also. Okay, now, so if you see, as we already discussed what is a pod and container, I'm not going to cover it again. So let us go with the component called Docker. So using Docker, containers are created. So what is the purpose of component called Docker? Using Docker, containers are created. Okay, so let us take the other component in the worker node, which is nothing but the kubelet. So the information sent from the scheduler from the master will be received by the kubelet component in the worker. Now kubelet will communicate with the Docker engine and create the container. Not only creating the container, it will also monitor the container, and it will also ensure the container's health is, or the health check will be done. So kubelet is the one in the worker which will be actually creating the container by talking to the Docker daemon. Clear? Now kubelet is the one which will collect all the information about the machine or the container, and it will send back the information to the scheduler. Now we have another component called Kuproxy. In Kubernetes, the communication between the pods or within the cluster all happens because of the component called Kuproxy. So if you have Kuproxy, the communication between this pod and this pod and this pod and this pod, or this machine with this machine with the master and this machine with the master, all this is possible because of the component in the worker node called Kuproxy. So with this we are ending, or I think we have very much discussed on every component in the Kubernetes architecture in detail at very higher level. So the next thing is, as you see, for a DevOps engineer, he will be having 4 clients or 4 users. So who are the 4 users? So it is, one will be the developing team, other will be the second will be the QA team, followed by the UAT team, and then the production team. Now in which scenario or the use case we will be using this style of architecture? So that is what will be our next video, where we will take a use case and set up this entire architecture in QA environment or dev environment, and I'll tell you why we require the exact architecture as you are seeing on the screen in QA or dev environment, but not in UAT and prod. So there is a use case which we have to understand, which is what the interviewers expect in the interview. So let us carry on with the next video, so that you'll have good hands-on how do you set up a Kubernetes master separately, 2 worker nodes separately for a QA environment. I mean to tell, we'll be creating a Kubernetes cluster for QA environment in short to tell. Okay, thank you and have a good day.